Students, in this lecture, we will study about the division of errors. To find the division of errors, we will have an expression R equal V upon I. This R is the resistance of any unknown wire. In the measurement of resistance of the wire, here errors are produced. Okay, so due to this carelessness, here error is produced in the measurement of resistance of the wire. Okay, and you know that the formula of resistance is V upon I, means this is the division. The resistance is equal to the division of potential difference and current. So what are the errors founded here? We will calculate. Means we will have to find the division of errors in the measurement of resistance. Okay, so let's we understand it. Let first physical quantity is A and second is B. These physical quantities are measured, and let the division of A and B is equal to Z. This Z is the result of division of two physical quantities, and during the measurement of these physical quantities, the error in the first physical quantity is del A and the error in second physical quantity is del B. So the total amount of first physical quantity will be A plus minus del A, and second physical quantity will be B plus minus del B. So the total of the division will be Z plus minus del Z. It will be equal A plus minus del A and B plus minus del B. It will be there. Okay. Now here we can take common A from numerator, B from denominator, and we can also take common from this Z. So on taking the common Z, it will 1 plus minus del Z upon Z. To understand this, in this step, Z plus minus del Z is there. Multiply by Z and divide by Z. Here take Z as it is and multiply this Z inside the bracket. Then it will be Z plus minus del Z upon Z. Okay, and it will be Z upon Z plus minus del Z upon Z. So Z will cancel this Z. So the value will be Z. Here 1 will remain 1 and plus minus del Z upon Z. This is the value. So we can write here direct, and in the right hand side, when A is taken common from numerator, then inside the bracket here will be 1 plus minus del A upon A, and in the denominator, when B is taken common, so B will be there, and inside the bracket 1 plus minus del B upon B will be. This equation can be written as Z plus minus del Z upon Z equal A upon B 1 plus minus del A upon A upon 1 plus minus del B upon B. But A upon B is equal Z, this one. So this equation will become 1 plus minus del Z upon Z equal Z and 1 plus minus del A upon A from here, and 1 plus minus del B upon B. because this is the product, that's why z will be cancelled by this z. So here will be 1 plus minus del z upon z equal 1 plus minus del a upon a, okay, upon 1 plus minus del b upon b. This equation can be written as 1 plus minus del z upon z equal 1 plus minus del a upon a. If we are taking it in the numerator, then it will change in the product and it will become 1 plus minus del b upon b minus 1. You know that del a is very small value as compared to the a. So this step is very small. Okay. You would have studied about the binomial theorem. 1 plus x to the power n. If x is very small than 1, then the expansion of this term will be 1 plus x n will be equal 1 plus power n into x. Okay. If the power is in negative like that, minus n, so it will be 1 plus minus n into x. This is the expansion. So what will be this? This will be 1 plus minus n x. Okay. So if power is in negative, so here will be negative. Okay. In the same case, this is very small value and this is also a small value. So on expanding by the binomial theorem, so we will get 1 plus minus del z upon z will be equal, the expansion of this term will be 1 plus minus del a upon a, because power is 1. Okay. And here expansion of this term will be 1 plus minus, and here minus will be there. So this minus plus minus, and this minus and this minus plus. So here will be del b upon b. But there is no change in the minus plus or plus minus. That's why minus plus is also written as plus minus. So it will be 1 plus minus del a upon a into 1 plus minus del b upon b. And it is equal 1 plus minus del z upon z. And what will be this? Implies 1 plus minus del z upon z equal, on multiplying 1 into 1 and del a upon a into 1, it will be equal del a upon a. Now 1 into del b upon b equal plus minus del b upon b, and multiplication of del a upon a into del b upon b, plus minus del a upon a into del b upon b. 1 into 1, 1. 1 and del a upon a into 1 equal del a upon a. Now 1 into del b upon b equal del b upon b, plus minus here because there is plus minus. Now plus minus del a upon a into plus minus del b upon b will be del a upon a into del b upon b. 1 will be cancelled by this one, and this step del a is very small value and del b is also small value. So the product of del A upon A into del B upon B will be negligible. So from this equation we will get plus minus del Z upon Z equal plus minus del A upon A plus minus del B upon B. This have been neglected. So this is remaining part. Plus minus del Z upon Z, we can take plus minus from both terms. So plus minus del A upon A, del B upon B. Plus minus cancelled by this plus minus. So here del Z upon Z equal del A upon A plus del B upon B. Here in the division of two physical quantities, total relative error is equal to the sum of the relative errors in individual physical quantities A and B. This is the formula. To understand the division of errors more clearly, let's we understand by some examples. Okay. In this example, the resistance R equal V upon I, where V equal 100 plus minus 5 volt and I, that is current, equal 10 plus minus 0.2 ampere. Find the percentage error in capital R, means in resistance. Okay. You know that if two physical quantities are given A and B, then their division is A upon B, and let it is equal Z. For this division, the formula of division of errors is equal to the del Z upon Z equal del A upon A plus del B upon B. This is the expression for the relative error for the division of errors. Okay. So the percentage error of the division will be del Z upon Z into 100% equal del A upon A into 100% plus del B upon B into 100%. Okay. You have to remember here that the formula of percentage error for the product of errors is same as that of the formula of percentage error of division. Okay. So you have not to confuse here. 100 plus minus 5 volt and current flowing through the resistor is I equal 10 plus minus 0.2 ampere. And the formula of resistance is R equal V upon I. This is the division of two physical quantities. So the relative error in the resistance will be del R upon R equal del V upon V plus del I upon I. This is the relative error. And what will be the percentage error? The formula of percentage error for the resistance will be del R upon R into 100% will be equal to del V upon V into 100% plus del I upon I into 100%. This is the formula of percentage error and this is the formula of relative error. Okay. So the percentage error in the resistance del R upon R into 100% will be, on putting the value of del V, this is the value of potential difference. In this value, after plus minus, this will be del V and this will be the value of V. Okay, so on putting the value in this equation, the value of del V is 5 and the value of V is here 100. 100 n into 100% plus here plus del I. This is the value of current. Here this is the value of del I and this is the value of I. So del I is 0.2 upon I. The value of I is 10 and into 100% this one. It will be 5 into 100 upon 100% plus 0 into 2 into 100. 0 into 2 into 100 upon 10%. 100 cancelled by 100. This one 0 cancelled by this 0. So here 5 and percent remain and plus here 0.2 into 10 remain and percent, or 5% plus on multiplying it will be 2%, and this is equal R del R upon R into 100%. Okay, or this will be 7%. So the percentage error in the resistance of given wire is 7%. Okay, it is very simple example.